Hello everyone and welcome to C Programming Tutorials. In this C Programming lesson, we provide a concise tutorial on linked lists in C. In particular, we explain how to Number 1. Define a linked list by using C structures. Number 2. Develop minimal C code that creates a linked list. Number 3. Print the linked list. And number 4. Erase the complete linked list. In the other parts of this tutorial series on data structures and algorithms in C, we will explain how to perform more advanced operations on linked lists. Keep in mind that in this tutorial, we keep the implementation of linked lists as simple as possible in order not to blur the presentation with too many C implementation details or advanced C concepts. The implementation is not optimal and not completely robust. However, it is simple and consequently it enables a student to understand the basic concepts. And here's the copyright notice. This lesson video developed code files and documents should not be copied, redistributed, or posted on public or private websites, public or private code repositories, or social media platforms. This lesson and all the provided study materials are strictly for personal use. Without the permission of the author, this lesson and the provided material should not be used for commercial purposes and for training of engineers working in companies. This lesson and the provided material should not be used as lecture materials on online learning platforms and in university courses. This lesson and the provided material should not be used to train an AI algorithm or a large language model. First, let's define a linked list. A linked list is a data structure that consists of nodes that are linked together by using pointers. A node in a linked list is a data structure consisting of stored data or a data object and a pointer to the next node in the linked list. And here is a brief illustration of a single node inside of a linked list. We can see that the node is a data structure consisting of two blocks. This first block contains stored data. Stored data can be integer, floats, strings, objects, arrays, windows, images, or any other user-defined data type. And the second block of the data structure called node is the pointer to the next node. That is, this pointer over here contains the memory address of the next node, and it points to the memory location. For example, over here I have one memory location, and over here I have another memory location. This memory location is actually the memory location at the beginning of the memory space that stores our node data structure. And this link over here, or this error, represent a link from the previous node. In this tutorial, we call the pointer to the next node as the link. That is, this part over here is the link. In the C programming language, nodes are usually implemented as C structures. Over here, you can see one example of a declaration of node. We type struct, then I will call my node simply as node, and inside I have two blocks. This declaration int stored data denotes this block over here. That is, this node will store integers, and over here we actually have a recursive definition or recursive declaration. Namely, over here we say that this link will point to the type struct node. This is perfectly okay, although over here we have declaration and inside we are referring to this declaration. That's perfectly fine. To properly define a simple linked list, we need to declare a head pointer of the struct node. We call the head pointer simply as head in this tutorial. Over here you can see one example of a linked list. Here's our head pointer, or simply head. Head points to the first node in the linked list. Now, The link of the last node in the linked list should be a null pointer. This pointer denotes the end of the linked list. In this tutorial, we use null to mark the end of the list. That is, the list ends with this link null, and it starts with the pointer head that points to the first node in the list. Linked lists are dynamic data structures. Nodes are created by using the malloc function and the returned pointers. A pointer points to the node struct object and not to the data objects stored in the node. We can expand the list by adding new nodes or shrinking the list by erasing some nodes. As mentioned previously, the address of the first node in the linked list is stored in a separate pointer of the type struct node that is called head. It's very important to preserve the address of the first node in the head pointer, since otherwise we might not be able to access particular nodes in the linked list. In the sequel, we explain how to implement linked lists in the C programming language. However, before I start with explanations, I need to mention the following. First of all, to edit C code files, I'm using Microsoft Visual Studio Code. However, you can use any other C or C++ editor. Then, to compile C code files, I'm using the GCC compiler. I installed the GCC compiler together with MinGW software development environment. Consequently, if I type where GCC, you will see from where I'm executing GCC. I created a separate video tutorial explaining how to install the GCC compiler and the MinGW. I will post a link to that tutorial in the description below. I strongly suggest you that you learn how to compile C code files from the command line, and consequently in this tutorial I will use the command line approach to compile my C code files. Let's start Visual Studio Code. Let's create our empty C file. Click on File, New File, and I will call the file as linked list1.c. Here it is. The first step is to include the necessary header files. First of all, we need stdio.h and we need stdlib.h. We need stdio.h since we will be printing messages and we will read numbers from the terminal. Then we need stdlib since we will be using the malloc function. Over here, let's declare our node. Consequently, let's type struct node. Don't forget the semicolon. And let's declare the integer that will be used to store the data. I will call the integer stored data. And let's declare our link pointer. I will call this pointer struct node. This will be the type, and the name of the pointer, as I mentioned previously, will be link. The next step is to define our main function. So let's write int main, and over here we return 0. Now we are ready to explain how to implement the linked list. For that purpose, let's go back to our slides and let's first graphically explain how to create head and first node. Whenever you want to create a linked list, you first need to create a pointer that points to struct node. This pointer is called head, and we initialize this pointer to null. Later on, this pointer will actually point to the first entry in our linked list, that is, at the top of the linked list. To create the head pointer, we need to type struct node pointer symbol. This means that we are declaring a pointer that points to struct node, and we call this pointer as head, and we initialize it with null. At the end, you will have a pointer that will be equal to null. The next step is to create our first node. To create our first node, we need to use the function malloc. The input parameter of the function malloc is the size in bytes of the object that we want to create. To retrieve the size in bytes of our struct node, user-defined data type, we need to use the function sizeOf. The function sizeOf will return the number of bytes that are necessary to store our struct node, and we pass this number of bytes to our malloc function. The malloc function will reserve the memory space, and it will return a void pointer to the beginning of this memory space. That is, it will return the pointer to the very first memory location inside of the reserved memory location. Since the returned pointer is a void pointer, this symbol over here will automatically cast the symbol, or actually the pointer, to be struct node star. That is, over here we are doing implicit pointer casting or type casting to struct node pointer. And we assign this address, that is the address returned by malloc, to this pointer, pNewNode. At the end of the day, the pointer pNewNode will store the memory location that marks the beginning of the memory space reserved by malloc. And at the end of the day, we will have this situation, we will have pNewNode that will point to the memory location that will be used to store struct node. Okay, let's implement these two steps in C. So let's type struct node star head is equal to null. Okay, this is our head pointer. Next, we need to use malloc to reserve memory space. So let's type malloc. Then we need to type size of struct node. This will reserve the memory location for storing struct node, and it will return a memory address that marks the beginning of the reserved memory space. Then we will store this memory address inside a pointer that we will call struct node. This is a data type with a star, and the pointer will be called pNewNode. And here it is. Good. Next, we need to execute these three code lines. The first line will store an integer 1 inside of store data. Consequently, this block over here in our node will contain 1. Next, we need to set the link of our new node. So we are writing pNewNode, its link is equal to head. What does this thing mean? We're saying that the link of our node should be pointing to the place where head is pointing. Since head is a null pointer, pNewNode, its link, will be equal to the null. And we will have the situation over here. And then finally, what we need to do, we need to shift P at the top. And we write head is equal to pNewNode. What's happening right now? Head is now pointing to the memory location that pNewNode is pointing to. That is, head will point to our new node. And after these 1, 2, 3, 4, 5 code lines, we will have this situation. Head will point to the first node as well as the pNewNode. Okay, let's implement this in C. So let's type pNewNode store data is equal to 1. Here we are simply storing an integer 1 inside of the stored data block of our node. Then after that, we need to set the link. So we type pNewNode, we get the access to link, and the link should be equal to head. Since head is null, link will also be null. And finally, we need to adjust the head. Head is equal to p new node. That is, head will now point to the newly created node. And that's it. We created the first node, and our linked list contains only a single node. The next step is to create the second node and to link it to our linked list. Here is the current situation. We have the head pointer and the pnew node pointer, and both of them are pointing to the first or to the top node inside of our linked list. Then we need to write this line of code. pnew node is equal to malloc size of struct node. The function malloc will reserve a memory space that is necessary to store struct node, and it will return an address of the beginning of this memory space. This address will be stored in a pnew node. After executing this line, we have this situation. Head still points to the first node inside of our linked list. However, pnew node doesn't point anymore to the first node. It points to newly created node in the memory space. And nothing is stored in this new memory space. This is our new node. Then after this command, we again need to write these three lines. The first line will store integer 2 inside of our new node block. That is, over here we will have 2. The next command line will set the link of the new node to point to head. That is, this link over here will point to head. That is, it will point to the previously first node inside of our linked list. And then after doing this, we simply need to shift the head such that the head points to newly created node. After executing these 4 lines, we will have this situation. This is our newly created node. We stored number 2, and we set its link to point to the first node in the linked list. This is the first node before actually including this new node. Then we shifted simply head at the top, and now this new node becomes the first node. Note over here that pnew node still points at this newly created node. That is, from here we conclude that we always add the nodes at the top of the linked list. That is, whenever you create a node, whenever you set the values, you will always put it at the top of the linked list. And this is a general principle for creating linked list. We will just add the nodes on top of each other. Okay, let's implement these 4 steps. Create and link the second node. Let's write a comment such that we know what we are doing. So let's start. Again, we write pnew node is equal to malloc, and let's see what are we reserving. We are reserving size of struct node. Size of will return the number of bytes necessary to store struct node, and malloc will reserve this memory space, and it will return a pointer to the beginning of this memory space. This pointer will be stored in the pnew node. Then we need to set the store data. So let's type pnew node. Let's access the data, store data, and let's store number 2. Then we need to type this pnew node. Its link is equal to head. Here we are linking this second node with the first node created over here. And then finally we need to shift the head. Consequently, we need to type head is equal to pnew node. And that's it. Now we have linked the second node, and the second node is at the top of the first node. Next, let's create the third node and let's link it to our linked list. Again, the third node should be added at the top of the linked list. To add the third node, believe it or not, we just repeat the previous 4 code lines. That is, over here we reserve the memory space and we return the pointer to the memory space, and again we store this pointer in the pnew node. Then over here we set the data that will be stored inside of our new node. Then over here we linked our new node to the linked list, and then finally we move head at the top of the linked list. As the result, we will have this situation. Here is our third node. This third node is added at the top of the linked list. Over here, we linked this node with the second node, and that's precisely done over here. And finally, we shifted the head such that the head points to the top of the linked list. And this is very important to keep in mind. Head always need to point to the top of the linked list. That is, to the first node in the linked list. And now our linked list looks beautiful. We have third node, second node, and the first node. Perfect. Let's implement this step in C. Let's type create and link the third node. And let's again type p, new node is equal to malloc size of struct node. Perfect. We reserve the space and return the pointer. We store the pointer inside of the pnew node. Then let's set the store data pnew node. Store data will be equal to 3. Then let's link this node with our linked list. We simply need to type this, and then we need to type head is equal to p new node, and that's it. Simple as that. Now we have created 3 nodes and we link them together. However, we need to investigate the accuracy of this process, and the best way to do that is to actually print the linked list. But before I explain how to print the linked list, note over here that I don't need anymore the pnew node. Consequently, I will set it to null. Over here, by setting it to null, we are not actually losing access to any of the nodes. Why is that? That's because the head points to the top of our linked list, and by just following the links to our linked list, we can retrieve and get access to any node inside of linked list. Note over here that you shouldn't reassign head. If you reassign head to point to somewhere else, you will lose complete access to the linked list and you will create a memory leak. So keep in mind that this very important thing. To print integer values stored in nodes of our linked list, we are going to define an iterator. In our case, we are going to implement an iterator as a pointer to the type struct node. That is, this iterator will be a pointer to a node. Then we are going to use this iterator and we will move from one node to another. We move from one node to another by simply following links. And we are going to iterate. Once we are at a particular node, we are going to simply retrieve the data and we will print the data. We will stop the iteration until we reach this last node. How do we know that we reached the last node? Well, the link of the last node is null. And we can use this fact to create a statement that will check if the link of the last node is null, then stop the iteration and you reach the end of the linked list and you printed all the entries. Let's implement this in C programming language. First of all, let's define our iterator pointer. It is of the type struct node, and I'm going to call this pointer pCurrent node. And I will initialize it with head. That is, this pointer is equal to head and is going to point at the first element inside of our linked list. Then over here, I'm going to define a counter. This counter will be used to print the current node. And let's write our while loop that will iterate through the nodes. The condition over here is p current node not equal to null. That is, we are going to execute this while loop until p current node is not equal to null. When p current node becomes equal to null, we will break the while loop. Inside of this while loop, we will first retrieve the number. So we will simply type int number is equal to p current node, and we will access the stored data. Then over here, we will do this print statement. We will type value stored at the node. Let's print the number of the node. This is our counter. And then let's print the value. And let's do the new line. Over here, let's type counter and number. Perfect. This will simply print the number stored at a particular node. After that, we need to decrement our counter, and we need to do this. We need to simply step to the next link. To step to the next node, not a link, this is very important. Let me repeat. The next step is to step to the next node. To do that, we need to type this. We need to set the iterator to be equal to the link of the iterator. That is, p current node will be now pointing to the next node in the linked list. That is, we go one step down the linked list. And that's it. At this point, we can actually try to compile this code. However, it's not a good idea to compile the code at this point. Why is that? Well, note over here what we did. By calling this malloc function, we reserve the memory space. 3 times we call the malloc function, and 3 times we reserve the memory space to store struct node. However, we didn't release this memory space. That is, we need to manually erase our linked list such that we don't create a memory leak. In this particular case, we only have 3 nodes that are maybe 60 or 80 bytes in total, maybe even less. And it might not be a big deal if we just run this code. However, standard practice is to free the memory. To free the memory, we need to do this. First of all, we need to set back our p current node to point to the top of our linked list. Then over here, inside of this while loop, we need to erase all nodes. To erase all nodes, we need to do this. First of all, the condition is p current node not equal to null. Why we are doing this? Well, we know that if p current node becomes equal to null, we reach the end of the list. That is, by doing this while loop, we will simply iterate through every node, and we are going to erase every node. So let's do this. First of all, we need to set the head to point to the correct node. So we need to type head is equal to p current node its link. Let's explain this. Once I execute this command, head will be pointing over here. However, if I go back and I see what's happening, p current node will still point to the top of the link. Why I'm doing that? Well, I simply want to erase this first node. And to erase this first node, I need to move the head to point to the second node in the link, since this third node will be erased. Okay, so let's do that. This is how we move our head. Then we need to erase the node. To do that, we simply type free p current node. This command over here will erase this complete node. However, we are not losing link because the head points to the second node over here. And then finally, we need to move the P current node again, and we need to set it to head. Now, after this command, P current node and head will point to the second node. And that's it. Simple as that. We are simply iterating through the list, and we are erasing every node until we reach null. At the end of this while loop, both the P current node and head node should point to null. So let's test this. Let's type check if we erased the linked list, and let's type over here if head is equal to null, and let's print the message, print f list is erased, and let's do this, and that's it. Let's save this, and now we are ready to compile and run this code. The next step is to compile and run this file. You can do it in Visual Studio Code. Namely, you can click over here, click on Run C++ file, and if the GCC compiler is set inside of your Visual Studio Code, you can compile and run the file. However, I don't think it's a good idea to compile the file by using Visual Studio Code. A better idea is to do it through command line. So let's go back to our base folder and let's locate our source file. But before compiling, make sure that you saved the file. Over here, to compile the file, we need to call the GCC compiler. I'm calling the GCC compiler like this: GCC, then this option W all, then the option W. Option W all and W will force the compiler to print all the compiler errors and warnings. And this last option, output, means that we want to specify the output executable file. So let's type. I will call the output executable file also linked list. And the last input parameter of this command is the name of the source file. The name of the source file is linked list C. Let's run this and let's hope that there are no errors. There are no errors or warnings. This is a very good sign. Then let's again list the content of the folder, and we can see linked list 1. Consequently, let's run linked list executable by simply typing this, and here it is. Voila! Let's compare this output with what is written in our code. Let's go, let me minimize this like this, and let's see what we wrote. Okay, let's see. Here's our first node. As expected, the first node is at the bottom of the list. Then here's our second node, and here's our third node. Works perfectly. Now, let's modify this code by adding a new link, or better to say a new node. I will simply copy and paste this piece of code after create link third node, and now over here I will type create and link the fourth node. And let's store over here 15. Look how it's easy to add new nodes. You can simply copy and paste the same piece of code. So let's save this. Let's go back to the command prompt, and then let's repeat the compilation, and let's now run again the code. And now here it is. We have 4 nodes inside of our linked list. Again, this is the last node, the third, second, and first. Okay, that's all for today. I hope that you like this video. If you like the videos I'm creating, please press the like and subscribe buttons and see you in the next video tutorial.